Dear students, I am A.K. Misra, PGT Physics, KV1, Armapur, Kanpur. Hope you are fine in your home with your parents. In this pandemic situation, we teachers are bound to take virtual classes from home. And in today's class, we will discuss the new topic, and that topic is uniform motion and non-uniform motion. You know, uniform motion in which an object moves with uniform velocity along a straight line uniform velocity along a straight line. Let us consider here the points A, here point B, point C and point D. These points are at equal distance, and that distance is here AB. Let that is x distance. And BC, again it is x distance. CD, it is x distance. Particle or body or object moves from A to B in time interval, let T1, and from B to C is T2, from C to D is T3, but all these three times are equal, let that is T. Such type of motion of an object is called the uniform motion. Means equal distance traveled in equal time interval. Equal distance in equal time interval. We can graphically represent the uniform motion here, such as, let us see this graph. That is the graph between position and time. Here you see the time in second and position is in meter. The start point is here O, and from O to, in x-axis there is time in second, 2 second, 4 second, 6 second, and position is from two bodies moving in a straight line path. You see here the distance 2. From 3, time is 2 to 3, position 2 to 3, 2 meter to 3 meter, moves in 2 seconds, and next 1 meter 3 to 4, again it is time, and that is 4 seconds, means 2 seconds, covered that distance in 2 seconds, and from 4 meter to 5 meter goes from 4 to 6 second, means again it is 2 second. The time interval is 2 second in each position by traveling 1 meter. By traveling 1 meter, that takes 2 seconds. This is the position time graph for the uniform motion. We can see here velocity time graph. In one axis there is velocity, in y-axis velocity, unit of velocity here it is meter per second, and time in second. Velocity is not changing with time. Velocity is not changing with time. You see here, at any instant of time, suppose in this time, by multiplying velocity to the time, we get the distance covered. Distance covered. Means area under velocity time graph, or you can say the area under velocity time graph, this area under velocity time graph gives the distance traveled by the body or distance covered. Velocity time graph gives this result, and that is the distance covered. And now the non-uniform velocity. In non-uniform velocity, you see the equal time interval, let OA, OB, OC, OA, AB, BC. OA, AB, BC, these are the equal interval of time, equal interval of distance x, and they covered, OA covered in T1 time interval, AB covered in T2 and T2 time interval, and BC the same distance travelled in T3 time interval. You see here T1, T2, T3, these are not equal, and in uniform motion these T1, T2, T3 was equal. Therefore, in uniform motion, equal distance travelled in non-equal time interval, or in other words, in equal time interval, the distance travelled is non-equal. A non-equal distance covered in equal time interval. There are so many examples of non-uniform motion and uniform motion in daily life. One example I am quoting here. Suppose your school is from home is 3 kilometer distance. Your school is 3 kilometer from your home. You traveled this distance by the bicycle in 3 slots. In 3 slots, first 1 kilometer in 5 minutes, next 1 kilometer in 10 minutes, next 1 kilometer in 7 minutes. This is the example of non-uniform motion. Means now you understand very well that non-uniform motion is the motion in which body travel equal distance in unequal time interval or vice versa. In case of non-uniform motion, here is a position time graph. You see the position of a body is from A to B traveled in time interval, different time intervals. Here it is T1 time interval, and from C to D it travel in time interval T2. Therefore, this is the position time graph that represent the non-uniform motion. One numerical question that is based on the non-uniform motion and uniform motion. In which you see here a body is moving with velocity 50 meter per second. A body moving with velocity 50 meter per second and moving for 3 seconds, and then next for 3 seconds body is moving with the velocity, with the negative velocity 30 meter per second. So you just find what is the distance covered and displacement covered. Here negative velocity shows the velocity of an object once moving in one direction, suppose in this direction, and then moving in the opposite direction. Means in one direction body moving with 50 meter per second, and in other direction now it is moving with 30 meter per second. One is taken as positive, another taken as negative. As you know, the velocity time graph gives the distance traveled, and this distance traveled is we can find by calculating the area under the velocity time graph. Here two slots, one is by blue color in which velocity is 50 meter per second and time is 3 seconds. Their product is 150. Means the distance D1, the distance D1 is equals to 50 into 3, and that is 150 meter. And for the second, the distance is minus 30, that is the velocity into time 3 means minus 90 meter. Ultimately, if we find the distance, total distance covered, and that is D1 plus D2, means both of the distances, one is 150 meter, another is 90 meter. Their sum 150 plus 90, and this is 240 meter. And displacement, that is D1 minus D2. Displacement means body is once going from in A point to B point, and now from B to A the body is at this position P. The distance is 240 means total path covered, and the displacement is the position initially and finally of the body. The final position is at B, initial position was at A. Their difference is 150 minus 90, and that is 60 meter. This is the distance and displacement. Distance is 240 meter and displacement is 60 meter. Now another question, in uniform motion is, suppose there is some distance from A to B. This point is A and point is B. The distance between A and B, that is x kilometer. A car is moving from A to B, with the speed 50 kilometer per hour. After reaching the car at the point B, now it returns from this is the way, and now it returns from B to A with the velocity 40 kilometer per hour. So you wish to find the average velocity, and average velocity and average speed. So let us see average speed. First of all, average speed. Average speed is the total distance covered. You know, total distance covered is here 2x. X plus x and total time taken. Time is the distance divided by speed. This is the time t1 and time t2, x upon 40. You can compile it. Means average speed is equals to 2x upon 50, 40, 200 then 4 ja 4x plus 5x. Now it is equals to 2x upon 9x into 200. So x is cancelled with another x, means 400 by 9 kilometer per hour. That is the average speed. And average velocity it comes to total displacement divided by time taken. Displacement in this case, body start from A to B and then return it B to A, means displacement is 0. Time taken whatsoever, the average velocity of the body should be 0. The average velocity of the body should be 0 because there is 0 displacement, and average speed of the body should be some finite quantity. From this, you can better understand the concept of uniform and non-uniform motion by giving these examples. Hope that you can understand this topic, and this is all about the topic that I taught here. Okay, I will teach you another topic on next day, in the next day class. Till then, goodbye. Thank you very much.